Instrumentation in differential scanning calorimetry. A typical differential scanning calorimeter consists of two sealed pans, a sample pan and a reference pan. These pans are covered or composed of aluminium, which acts as a radiation shield. The two pans are heated or cooled uniformly while the heat flow difference between the two is monitored. This is done at a constant temperature, but it is more commonly done by changing the temperature at a constant rate, a mode of operation which is called as temperature scanning. During the determination, the instrument detects differences in the heat flow between the sample and reference. This information is sent to an output device, resulting in a plot of the differential heat flow between the reference and sample cell as a function of temperature. When there are no thermodynamic, physical, or chemical processes occurring, the heat flow difference between the sample and reference varies only slightly with temperature, and it shows up as a flat or very shallow baseline on the plot. However, an exothermic or endothermic process within the sample results in a significant deviation in the difference between the two heat flows. The result is a peak in the differential scanning calorimetry curve. The differential heat flow is calculated by subtracting the sample heat flow from the reference heat flow. Following this convention, exothermic processes will show up as positive peaks, that is above the baseline, while peaks resulting from endothermic processes are negative and will show below the baseline. The sample is placed in an aluminium sample pan, which is then placed in the sample cell. The reference consists of a matched empty aluminium sample pan that is placed in the reference cell of the instrument. The sample pans are designed to have a very high thermal conductivity. Sample sizes ranges from 0.1 to 100 milligram. The instrument cells are airtight to shield the sample and reference from external thermal perturbations. This allows the experiments to be performed under variable pressures. Now, there are two main types of differential scanning calorimeters. The first is known as the heat flux differential scanning calorimeter, which is shown in the figure. In this instrument, heat is transferred to the sample and reference through a disc made of the alloy constantan, or in some cases silver. The heat transported to the sample and reference is controlled while the instrument monitors the temperature difference between the two. In addition to its function in the heat transfer, this disc serves as part of the temperature sensing unit. The sample and reference reside on raised platforms on the disc. Under each of these platforms, there is a chromel wafer. The junction between these two alloys forms a chromel constantan thermocouple. The signal from these sensors is then used to measure differential heat flow. The temperature is monitored by chromel alumel thermocouples attached beneath the chromel wafers. The second type of instrument is known as power compensated differential scanning calorimeter, which is shown in the figure. In power compensated differential scanning calorimeter, separate heaters are used for sample and reference. Both the sample and reference are maintained at the same temperature while monitoring the electrical power used by the heaters. The heating elements are kept very small, weighing about 1 gram. This is done in order to ensure that heating, cooling, and thermal equilibration can occur as quickly as possible. The sample and reference are located above their respective heaters, and the temperatures are monitored using electronic temperature sensors located just beneath the samples. Platinum resistance thermometers are used due to the high melting point of platinum.